A couple months ago, I released my Mr. X Behaviour Tree project and video showcasing the journey I went on developing it. From researching the fundamentals of a behaviour tree AI in video games to implementing a playable gameplay loop with traditional gameplay mechanics. Since then, I've had a ton of comments asking about how I optimise the game, given the fact there's loads of rooms, tons of assets, and real-time lights everywhere. Literally nobody asked about this, but I'm going to show you anyway. Some of you might recognise the engine. Now, as you'll know in previous videos, I have moved to Godot for however long I use Godot. While the techniques we talk about, I'm going to use Unity as a base engine for it. Don't worry, you can use these techniques in any other engine. We're just going to talk about the techniques I used to help me optimize this game. But keep in mind, you can use these techniques or implement a version of these techniques in the engine that you are using. These might not be the best implementation of these techniques I'm about to talk about, but so far these are the best ways I've implemented them. Again, let me know if there's a better way of implementing them. I'd love to know. Please let me know. First things first, texture atlases. What is a texture atlas? A texture atlas is literally an atlas of textures. Basically, you'll have one big texture that contains all the other textures. So, for example, here in my project, there were a couple models that I downloaded from places like TurboSquid or like basically asset stores. A lot of models had different textures applied to them. Some of them were duplicates of the same model. For example, the bin texture. If I go over to the bins in the back, it's literally the same model. However, it's got different textures applied to it. As you can see down here on the bottom right, this is a texture atlas. You can see there's a big black space here which has nothing in there. That is just literally because there are 4 textures for these bins. They are pretty much the same with nothing much different but the colours of the bin, for example. So when you're placing UVs for each model, you place them on this texture atlas in the right spots so that they have that texture. But they all use the same texture in the material. So they can all use the same material. For example, so like if I click here, and go to the mesh renderer here, it's Garbage Bins Atlas. This one will be Garbage Bins Atlas 2, and this one will be the same. So it basically means that it's not loading in multiple materials that point to maybe the same texture or different textures. These can be lumped together in the batching process and be rendered at the same time, especially since here in Unity they are ticked. So an even better example of how you can utilize texture atlases is with portraits. So if you see here on the screen, we've basically got 3 frames on the wall. All of them are using these wood textures. The UVs for the frame are in the same places as all of these other ones, but the main difference here is that the plane used to model the picture part of the picture frame, they're placed in different spots. So you can have, so here's the Outer Wilds one, here's the Ratchet & Clank one, and here's the Yakuza one, right? So literally, as simple as that. It is as simple as that. You literally just move the texture UV over the bit, and you can reuse the same texture for these different models. Easter egg, Easter egg, Easter egg. They all point to the same model. This is literally just this texture atlas here. We're back to it. That is it. That is texture atlases. It helps reduce the size, and many of the mainstream engines do use that sort of process, so take advantage of it. It is definitely something that is very useful if you've got even more heavy than this room, especially in like Unreal Engine projects. Although Unreal Engine has its own sort of like dance with optimization that I think is a little bit out of the scope of this video, but basically you can throw fucking Shrek 2 in there and it just renders it fine. Some engines are just going to be better at optimization techniques. I think it's important to say that right here, right now. But for other engines or engines in general, if your room is coated in assets that could benefit from a texture atlas, this might be something important for you. Most engines will have a profiler. The profiler is something that's talked about a lot, especially when you look at Unity tutorial videos and anything to do with optimization. It's a guaranteed topic. The reason for that is that it basically shows you what is happening in your game. That is from code runtime to rendering, memory, audio, video, physics, UI. This is specifically Unity, but it will do very much the same thing in most other engines. Obviously, I did this project in Unity, so I'll use Unity as a bit of a base. But don't let that deter you from this video or any of the techniques here. They are still very much applicable. You just have to find them. For example, in Godot's case, the profiler does exist, but it's just for GD script at the moment. You can't use C# with it. I'm sure that they will address that, given the fact that their implementation of C# is pretty banging, but there's probably some open source solutions there that might be useful, but it's very much something you should look into. For example, here, if we, especially in the Unity one, we can see the garbage collection allocation. Like you can see here, I could, there's something allocating GC allocation. Again, it's important if you're doing this in editor, it might be a slightly different, given the fact that there are some overhead to running it in the editor. For example, you can see different bits here, like you got the character controller. If I was running the game right now and was to run into Mr. X, you'd have the behavior tree functions being called here that have a lot of garbage collection, but we won't talk about that. We can just leave that in the past. Let's just leave it. I tried. I promise I tried. But a tiny bit specific to Unity here. I'm pretty sure that Unreal has something very similar, but there is also something called a memory profiler. This is really, really impressive. It's actually quite important for your game, especially if you want to run your game on lower end devices. You're going to want to check the memory of it, because not all devices are built the same. I'm pretty sure you know that, given the fact your computer probably isn't a fucking NASA supercomputer. So here's one I did earlier. This shows you a lot, basically. It shows you the size and the total size, the size in relation to the entire thing running at the time, native size. It shows you a lot of information basically about all these different systems. You've got render textures, 2Ds, meshes, materials. It will show you everything that's running at the time the snapshot is taken, so you can profile how much any particular scenario is going to take up for your for the target device. As you can see here, I've only just noticed this today, and I've only just fixed it because I didn't realise I had done this, so I'll get to that in a minute. This knife, for some reason, this knife has a very high size for its normal and occlusion textures. I didn't see this. I don't know why I didn't see this, because I used this tool before I kept pushing changes to itch, but I missed it. Don't know how. I think I'm stupid. That aside, this is a perfect example, and I can show you what steps you can then take. So for example, if we go here, select in editor. Literally select it in editor. Who would have thought? It will take you here. And as you can see, so for example here, look, it says that the native size was 170 megabytes. That is mental for such a small object and a normal map. Really, let's be honest. Here it doesn't say it because I have fixed it. This was checked. I do not know why that was checked. I want to say that Unity's gaslighting me, but I'm pretty sure I gaslit myself. So we're gonna leave it there. Damn it! By unchecking that and applying it. So if I show you what it was, so this is what it used to be, 85 megabytes. That then translated to 170 megabytes in the game. Unticking that and using the default thing that I had checked beforehand brings it down to 5 megabytes. That's pretty tasty. And I can show you, I took a second snapshot here. In fact, let me compare them, because you can actually compare snapshots, which is pretty decent. Fucking hell, Unity. thanks. I'm gonna have to close it. So as you can see, there are gonna be differences between these snapshots that don't necessarily relate to what we were talking about based on where I took the snapshot. I don't know quite what happened here, but ignore basically the count differences and the increase here. I'm gonna just tell you to ignore that. Because as you can see, a lot of these textures weren't being used in the previous snapshot. But just for example, in the target textures we were talking about, here already, look at that difference. There's a massive difference there of like 160 megabytes. So, but just by using this tool to profile what textures are being used, it's really useful, and I just sort of wowed myself this morning, to be honest. So far, you might already know the optimization techniques we've talked about. You might even know some of them to come. But it's important to remember that you don't know these straight away. It takes time to learn and research and figure out these sort of things. You've got to learn, which is only fitting. This video is sponsored by Brilliant. Learning new things and furthering your current understanding doesn't have to be laborious. It can be fun. With Brilliant, you have access to thousands of interactive lessons in maths, computer science, programming, and AI. Each lesson aims to teach you how to solve problems rather than simply memorizing solutions to help make you a better thinker. Brilliant prides itself on using the power of interactivity to solidify your understanding of the topics you choose, up to 6 times more effectively than simply watching lectures on the same topic. Programming can often feel a little daunting when getting into game development. With Brilliant's programming courses, you can learn how to program in Python, basic coding fundamentals, or even how to think like a programmer. Since I started strengthening my understanding of equations since I was a stupid little boy, I'm still very much an equation noob, but thanks to Brilliant, I really have felt better when seeing equations in game development videos, especially watching Sebastian Larg videos. He's quite literally a god at this point. If you're interested in trying everything Brilliant has to offer for free for a full 30 days and 20% off an annual premium subscription, visit brilliant.org/DarkDax or click the link in the description. You probably saw this one coming, and I have touched on it a little bit in a previous video. It's static batching, GPU instancing, and occlusion culling. I'm not going to go in too much detail, because if you want a bit more detail about these systems, go to my other video. I talk about it a little bit more in depth and give a bit more information about it. Static batching is all about making your objects static. For example, if you make objects static, especially in Unity, they can be batched in the GPU in the rendering process. What that basically means, a gross simplification of it basically, is that it will render it all at the same time, so it reduces draw calls. So instead of having a draw call for every single bin, for example, it will do one draw call for all the bins that are marked as static. Draw calls are basically how many calls it takes to draw everything on screen. This is very high. I'm very aware that this is quite high. It's just a setback of the project. I was learning a lot about it, but the aim is to get that as low as possible. There's going to be situations where you can't necessarily do that. As long as you test it on devices that you're targeting and it runs fine and doesn't affect player experience, don't worry about it too much. So GPU instancing is enabled via the material itself in Unity anyway, and that basically similar to static batching. They're all separate. They're all very different processes, but they all go towards reducing that draw call and optimizing the processing that is required by the GPU rendering process. This is more effective for lower vertex count models, and if you've got a metric ton of them. Craig Perko's video about GPU instancing is all you need to know about it. I basically point you there anyway in that video, so definitely check that out. It is incredible. Again, not just limited to Unity, although Unity again in that video is used as the base engine. And one of my favorite bits of optimization technique is the occlusion culling. I've already talked about it. Watch this video again. I'm going to plug it again for more detail, but occlusion culling is, if you can't see it, what's the point rendering it? There's frustum culling, which most engines do by default. I think some engines you might have to enable it, but in Unity it is done by default. That's basically, if it's behind you, what's the point? If I take the camera and go anywhere I want, thank you boundary break, you can see that all that stuff isn't being rendered. But yeah, I just realised you cannot see my mouse. That's going to be annoying, so I'm going to have to do some zooming. Good editing skills, here we go. Back to something a little bit more simple. Again, just to make you aware, I am using the HDRP pipeline, not using it very effectively. I mean, this game doesn't look particularly amazing, but one of the best things you can do for your game is to introduce quality levels. This is going to be very good, especially for target devices of various performances. I've set up some quality controls here, so if this is high, this is the highest one. If we go to medium, you can see that the textures are a little bit more compressed, shadow quality is a little bit ass, and then lowest is the textures are ass and the shadows are ass too. Like, I can show you a little bit over here, like you can see the shadow cascades, and shadow mapping is all a bit shit here. So here we've got some settings here. We've got windowed, obviously, because it's in the window. There's the thing, and quality settings here. Apply, just puts it into thingy. Rain quality, just put that on low. Literally, it doesn't change the quality of the rain. It just reduces how much rain's being shit out. There will be more nuanced ways of implementing these graphic settings. I mean, I don't know if you've actually looked at the graphics settings in Unity. It's a little bit daunting. It's definitely all just thrown at you. I mean, they've got some toggles here, but looking at this, I'm a little bit like, it takes a little bit getting used to. I've definitely forgotten them now, but towards the end of the project, I was a little bit more versed in where to go for what. So definitely take a look at that. Now, for something that was actually very core to my project is that basically, I don't know if you've noticed, there's a lot of real-time lights here. Why did I use real-time lights? Because I had plans. Scope creep cancelled those plans, and now I had to make a solution for that. I could have baked them, but at the start of the game, the generator is turned off, so the lights are all off, and then you have to turn the generator on, the lights turn on. Could have just added a little script, could have just had 2 baked light maps and swapped between the two, but I'm lazy and I'd like to create more effort for myself. Oxymoron. But basically what I opted in to do was a room system, and what it ended up helping me a lot more and create a system that is a little bit more flexible in what I can make it do. I've touched on this in the in the main video, so again, plugging that, go watch that video. I go into much more detail about what this is, so I'm not going to just explain how I made the room system, just going to explain what it is. The room system basically links rooms together. The game knows which room you're in and what rooms are next to it or linked to it, what rooms you can get to which room for. That's how the AI knows how to get to you if you're over here and he's over there, and you've got all these rooms to navigate through. Another thing is that I've got a room environment controller. I don't know why I said it like that, but there's a room environment controller, manager. What else is there? Let me just read my carefully placed notes over here. Object, and there's a subset of object called light. And I think that's a little bit obvious what that's for. So if I open this door, it will tell this room to activate. Based on whether a room is activated, it will invoke an event. That event can do anything, basically. It can, I don't know, turn the floors red if you wanted it to. It can, I don't know, disable the bin over there. Not quite sure. It could enable Mr. X. What I have also made it do is I have enabled it to turn on the lights. So if you're in this room, there's no point having the lights on. I found that in my project, this is something that I really needed because of my stubbornness, really. But I learnt a lot. So when I go outside into the courtyard, the lights turn on. So the continuity's there for the lighting situation, so you can look through windows and stuff like that, and it's all Gucci. This room is on, and you'll see in a second. that room will now be off once the door closes. So all these will stay open until I close the door. Bam. That system checks what room you're in currently. So basically, I log all the doors and all the rooms and environment controllers, so it knows what to do, and it's got it all cached, so it can do it quickly. But when opening the door, add it to the active doors, and then it goes through and sorts it all out. Basically, when the door shuts, it checks to see if it's contained in the active door list, removes it. Obviously, it gets the player's room currently. It activates that room if it's not activated already. Now, and then it uses link. Link is something in C# that allows you to do more sort of like query-based operations on collections. There's a little bit of overhead to it, but I think people are way too overly concerned about the overhead. It just gets all the connected rooms to the rooms that you're in. And then the ones that you're not in, it deactivates all of those. When the door shuts, it will realise this is the same room and keep it on. If this room was visible, if you came into this room, the door shut, this room and that room would remain enabled. So there are things. You can also do it for sound sources as well. So again, like I say, you can do it for anything. I'm overselling it right now. It's really not that big of a thing, but I found it really helped with the performance. Again, it's not lost on me that I could have really made my life 100% better. Something fun that I found might not be interesting to you, but it's an example of there are situations in game development that we just have to make our own solutions for. The game engine can only do so much. It's not for your project, it's to help you make your project. There may be a situation where you need to make your own rendering pipeline. There may be a situation where you just need to make your own tool to optimize a thing. It might just be that you need to make a little system like this to help compensate for anything that you deem a requirement, but could do with some optimization, basically. I mean, there will always be a better solution. For example, with the light thing, I could have just switched between baked maps for turning it to, especially the power generator. But originally, I was going to have the ability to turn on and off lights. Why? Who knows? But that was something I wanted, and it didn't get put in, and this is a solution I came with because I just wanted the project done. Bit of a workaround, yes, you could say so, but you could also say it was a system that is quite versatile and I could have taken to other projects if I was still using Unity. But that's that's fine. So yes, that is basically it. Those are some of the techniques I used to optimize this project. Some of them you probably knew, but I think it was just an interesting thing to do, to just show that there are things that you can do to optimize your game. There are some like little quirky things, there are some like obvious ones that are already built into the engine, and there are some that you might have to make yourself. And the example I gave at the end there about the room environment controllers and stuff like that is just an example of something that you might have to implement. So something to maybe think outside of the box a tiny bit. But yeah, I hope this video was useful. It was fun to make. Well, I was just sat here. There was no script for this. I don't know if you can tell. But yes, let me know in the comments if there's been a really interesting optimization that you've had to do yourself for your project, whether that be something you've never done before or something a bit more custom like I had to do for the room environment controller. But in the meantime, thank you so much for watching, and thank you so much to my patrons for supporting the continuation of this channel and myself. If you want to help with the continuation of the channel yourself, head on over to patreon.com/DarkDax and pledge as much or as little or nothing at all. At the end of the day, I'm glad you even watched. Now, if you'll excuse me, I'm going to go and squeeze more content out of this one project I made. See you guys next time. Bye!